Hello. This lesson is about question 2018 of HSC Mathematics Extension 1, question 14, part BI. By considering the expansions of bracket 1 plus 1 plus x in the bracket and the second bracket to the power of n and bracket 2 plus x to the power of n, show that n choose r times r choose r plus n choose r plus 1, r plus 1 choose r, plus n choose r plus 2, r plus 2 choose r, dot dot dot, n choose n times n choose r is equal to n choose r 2 to the power of n minus 1. Alright, so they are asking us to expand this and expand that and show that this is true. Why are we going to do that? Because first of all, why these two are equal? Because if you add this 1 and 1, you end up with 2, so you end up with 2 plus x to the n. So these basically expressions are the same expressions. The only thing is they have written them differently, so we can extract this identity. But how do we go about that? The easiest way of finding a way is looking on this one, expansion of this one. And as you can see, if we expand that, you're going to have different powers of 2 and different powers of x with different coefficients. But this specific term is when you have this term, when you expand that, you have this n r 2 to the n minus r x to the power of r. That is one of the terms which will occur when you expanding that. And as you can see, this coefficient of x to the r is here. So what they have done, they have equated the coefficients of x to the r when you expand this form and when you expand this form. So we do that and we put the coefficients and we see if we get what they are asking. Alright, so what we know first is 1 plus x to the power of n is 2 plus x to the power of n. So this is the left hand side, I'm going to expand this, and this is my right hand side, I'm going to expand that either. So on my left hand side, when I'm expanding, I'm considering this bracket as my second term and this as my first term. So basically assume you expanding a plus b to the power of n, and your b here is this bracket and your a is 1. Alright, so then you're going to have n choose 0, 1 to the power of n, 1 plus x to the power of 0, and n choose 1, 1 to the n minus 1, 1 plus x to the power of 1, plus n choose 2, 1 to the power of n minus 2, and 1 plus x to the power of 2, and dot dot dot, n choose r, 1 to the power of n minus r, 1 plus x to the r, plus n choose r plus 1, 1 to the power of n minus r plus 1, and bracket 1 plus x to the power of r plus 1, and we continue that all the way until we end up with the last one, which is n choose n, 1 to the power of 0, and 1 plus x to the power of n. Alright, one important thing in this expansion to be considered is why I put r here, and why I missed all these terms and started in the middle with 1 plus x to the power of r. The reason is, as we said, we are interested in x to the power of r. And that first time happens in the expansion of this. So in other words, all these terms we had so far, none of them are going to have x to the power of r. All of them are having highest powers below r. That's the first time we hit r. And this is going to be at the last term of the expansion of that, if I expand this again, this bracket. But all the terms after that are going to have x to the power of r in them. So for example, in this one, the second last term, when you expand this bracket, the second last term is going to have x to the power of r in there. Okay, and here the third last bracket, the third last term is going to have x to the power of r. Okay, now that is for the left hand side. For the right hand side, on the other hand, you're going to hit x to the r only once, because here each term only has its own unique x to the its own unique power of x. So if I expand this, it's going to be n, then choose 0, 2 to the n, x to the 0, n choose 1, 2 to the power of n minus 1, x to the 1, plus n choose 2, 2 to the power of n minus 2, x to the 2, and dot, dot, dot. Again, I'm starting with r because all these terms, none of them has r, and that is the only term which has r. And these ones also are not going to contribute to the coefficient of x to the r, because it is already above r, x to the r plus 1. Okay, so this continues. You can just expand it the way I've done it, and lastly you end up with n choose n, 2 to the 0, x to the n. Now we put the coefficients of x to the r equal from both sides. As I said, on the right hand side, that's the only one that you have. That's the only coefficient. So then you choose n, choose r, 2 to the power of n minus 1. But on the expansion of the left hand side, we are going to have lots of terms with x to the power of r. And as I said, the first time we hit that is in the expansion of that. So if you expand that, you're going to have n choose r. 1 to the n minus 1 is just 1, so we ignore it. And then you get, here you're going to have r, the last term of that, x to the r. Okay, so that is the first time you hit x to the r, and that's the coefficient of that. And as you can see, that appears here, n choose r and r choose times by r choose r. In the next one, this one, as I said, it's going to be second last term. So when you expand just this bracket, you're going to have r plus 1 choose r, r plus 1 choose r, and again I'm ignoring 1 doesn't matter. You're going to have x to the power of r, okay, in the expansion of that. Then it's going to be times by that, so it's going to be n choose r plus 1. Now the coefficient of x to the r in this whole term will be that. So n choose r plus 1 times r plus 1 choose r, which is happening here. Okay, and if you keep doing that, you will get all these terms. On the last one, on the left hand side, you're going to have n choose n, and then n choose r for the coefficient of x to the r. And you put that, as we said, to the coefficient on the right hand side, which we just talked about that, and you end up with the identity you've been asked to prove. Thank you for your attention.